Right, so one very important thing that electron configurations will tell us is the number of valence electrons within an atom, or ion eventually. So what is a valence electron? A valence electron is an electron in the highest energy level. Or N, principal energy level. The electrons in the valence electrons, or electrons in the highest energy level, are the electrons on the outside of the atom. So they're sometimes called outer shell electrons, especially in older texts. They are called outer shell electrons because, again, they're furthest away from the nucleus. They're on the outside of the electrons. And these are the electrons that are involved in chemical reactions. The primary electrons involved in chemical reactions. And that's why they're so important to us. Okay. So we did two electron configurations last time. We did carbon, which was 1s2, 2s2, 2p2. The highest energy level for carbon is energy level 2. And it has 2 electrons in the s and 2 in the p. So for a total of 4 electrons. Carbon has 4 valence electrons. The other element that we did the electron configuration for was phosphorus. It had an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p3. Phosphorus's highest energy level is N equals 3, and in energy level 3 it has 2 plus 3, 5 valence electrons. In addition to using electron configurations to show us how many valence electrons a particular atom has, it's also very easy to use the periodic table to give us that information, especially for the main group elements, the elements in groups 1, 2, and 13 through 18, or 1a through 8a. If we use the A numbering system, 1a through 8a, that will tell us the number of valence electrons. If you remember, carbon had 4 valence electrons. It is in group 4a. All of the elements in group 4 have 4 valence electrons. How many valence electrons did phosphorus have? It had 5 valence electrons, and it is also in group 5a. Five valence electrons for nitrogen, phosphorus, arsenic, even bismuth. Any element in group 5a has 5 valence electrons. So even though we didn't do the electron configuration for sodium, because it's in group A, we know, or 1a, we know that sodium has 1 valence electron. Additionally, one thing that's going to help us when we start to build molecules and learn about Lewis theory is to be able to draw electron dot structures. Now, electron dot structures are very simple. Electron dot structures. Sometimes we want to very quickly show how many valence electrons a particular element has by first writing the symbol for the element and then using dots to represent each valence electron that particular element has. So for instance, carbon had 4 valence electrons, and so we would draw 4 dots around its symbol. phosphorus had 5 valence electrons, and so we would draw 1, 2, 3, 4, 5. Okay, so you might ask yourself, can I draw 2 dots on the bottom or the left or the right? And yes, in general you can. What I usually do is I will start at the top and work clockwise. 1, 2, 3, 4, 5, 6, 7, 8 in that fashion, like that. I want to group electron dots on the top and on the bottom horizontal, and then electron dots on the left and right vertical. And that will prevent electrons from starting to look like bonds, which we will eventually start to draw. Okay. Sodium was another element. We figured out how many valence electrons it has. And so it had 1 valence electron. So very simply for sodium, we could draw 1. Chlorine is in group 7A. And so we know that chlorine has 7 valence electrons. And so we would draw chlorine like this. 1, 2, 3, 4, 5, 6, 7. Now I left the 1 lone electron on the left side. I could easily draw chlorine like this. 1, 2, 3, 4, 5, 6, 7. And that's perfectly fine as well. One thing you don't want to do, so these 2 chlorines are okay. You don't want to group electrons more than 2. Okay, so for instance, I wouldn't want to draw chlorine like this. 1, 2, 3, 4, 5, 6, 7. That wouldn't be a good way to draw electron dot structures. That primarily comes from the fact that, as we know, electrons exist in orbitals, and there's usually 1 or 2 electrons in an orbital, not 3, not 4. Additionally, you don't want to draw chlorine or the electron dots in, say, fashion like this, because again, that would start to look like a bond, and if we don't want to draw a bond, we don't want to show that it looks like a bond.